The word interior, what does that mean? Inside. Okay, good. So we're going to start by talking about pieces that cross over each other that are on the inside of the circle, and that's really important. That's on the inside. So in my first picture here, it says, if two secants or chords intersect a circle, then the measure of the angle formed is equal to half of the sum of the measures of the intercepted arcs. So here's all that's saying. If you have two lines that intersect each other on the inside of your circle and they are not at the center, so it's not a central angle, it's something somewhere else in the circle. To find the measure of these angles on the inside of the circle, I'm going to take the two arcs that are intercepted and find the average of the two. So I'm going to add them together and divide by 2. So here's what I mean. If you take a look at this angle 1 right over here on the left, the two angles that the two arcs that are intercepted with that angle are the two that match up in the same position. So since this one's kind of like on the left side, the two arcs that match up with it are the ones that are on the left and the ones that are on the right side of it. So that is arc AD and arc BC. So if I wanted to find the measure of that angle 1, what I would do is I would add together arc AD plus arc BC, and then I would divide by 2. I'm finding the average of the two, and that will give me the angle measure. So I'm going to add arc AD plus arc BC, and then divide by 2. That'll give me the measure of the angle 1. It will also be the exact same as this angle right here, because what kind of angles are these two angles right here? They're what? They're vertical angles. Yes, they make an X and they're right across from each other. So these two are exactly the same. I can use the exact same idea for angle 2 right here. Right, same idea. I have to add together the two arcs that are intercepted and divide by 2. So which two arcs would I be adding together for this one? A, B, and DC. Good. So I'm going to add together arc AB plus arc DC and then divide by 2. Oops, DC. Woo. Apologies. Arc AB plus arc DC divided by 2. And that'll give me the measure of each one of those angles. If I added up all 4 of those angles together, what should I get? 360 degrees. Good. Okay, so it's a good and easy, quick way for me to check if I got my answers right or wrong. So let's try an example. Number 1. You're going to find the measure, so that M beforehand means measure, the measure of angle AED. So AED is this angle right here. Okay, to find the measure of that angle, which two arcs am I going to add together? BC and AD. Good. So I'm going to add AD plus BC and then divide by 2. And so this one's super easy. Because you're already given those two arcs, all you have to do is add them together and divide by 2. So 45, I'm not going to write this out every time. I'm just doing it for the first one so you have an example. 45 plus 109 and then divide by 2. All right, what do you get? So add the two numbers first and then divide by 2. 77 what? Degrees. Very good. So the measure of angle AED is 77 degrees. Perfect. And you're done. So the arc plus the arc divided by 2 equals the angle. So again, you're just finding the average. Easy peasy. Questions on that? So far, so good, right? Not hard. All right, number 2. Measure of angle STR. STR. So that's this angle right here. All right, you give it a try. You should be able to do it. Try it out. Arc plus the arc divided by 2 equals your angle. So give it a try. Purple. All right, what'd you get? Katie got 149. Do we agree or disagree with her? Got some shakes? Yep. Beautiful. 149. So you add 186 plus 112, divide by 2. You get 149. Don't forget the degree symbol. That's it. Easy peasy. Yeah? Arc plus arc divided by 2. All right, let's try the next one. Number 3. Measure of angle YWX. YWX. Now, that's this angle up here. Okay. Now what?
Add the 81.4.
Okay, is that going to give me my answer?
Skipping 2. Agree.
Shouldn't we use the numbers to the angle?
Okay, so it doesn't give me my 2 intercepted arcs at the top and the bottom that match up with this angle. All right, I don't have those 2, but I do have the left and the right. And if I figure out the left and the right, I'm going to figure out the angles on the inside that are to the left and to the right. So I'm going to figure out angle YWV and angle XWZ. Now that's not what I'm asking you for, but that's okay. Let's still figure that out. How would I figure out that angle on the interior? What would I have to do? The pink one now. What's my equation? Was it? Right, so add the 2 together and divide by 2. So 43 plus 81 and divide by 2.
52 is the answer.
No, 62. Correct, 62, not 52.
Yeah.
Well, that's different. 62 and 52 are different numbers, man.
By 10.
Oh, that's big. Okay, now I know this angle on the right and this angle on the left are both 62 degrees. Great. But that still doesn't give me the answer to the purple angle at the top. How do I figure that one out? Subtract. Okay. Subtract what from 360? You got to take both 62s. Right? Not just one, because you're trying to get the whole thing's 360. You could do it that way. You could put 62 and 62 together, subtract from 360, divide by 2, or what's a faster way to do it? Oh, faster than that. Faster than that. It's a straight line. A straight line's how many degrees? 180. Yeah, you can just say, hey, look, there's a straight line. I know that straight line is 180. I already have 62 of the 180. I can just subtract those two numbers. But if you wanted to do it the 360 route, you'd still get the same answer. So you do whatever one works better for you. I'm lazy and I don't want to do that much work, so I'm just going to subtract from 180. But you're going to get the same answer regardless of how you do it. So to find angle YWX, we do 180 minus 62. And what do you get when you subtract those two?
118.
Beautiful. 118 degrees. Degrees. Don't forget degrees. Beautiful. So it took me one extra step, but that's fine. You need to figure out the other angle first. So notice that we're still using vertical angles. We're still using that a straight line is 180. We're still using that a circle is 360. These are things we're going to continue to use. All right, questions on that one? Okay, number 4. Now, what's different about number 4? This time I'm asking for the arc, not the angle. So I've got this arc at the bottom is 74. I've got this angle is 62. And I'm trying to find arc LK. All right. What do you think I should do? Wouldn't it be what? It would not. Nope, they're not. The arcs are not the same. The angles are the same. Well, so both angles would be 62, but that doesn't tell me what the arc is over here. So what did we do before? We divided what by 2? I could subtract from 360, but then I still got a problem because then I still have all 3 of these pieces left and I don't know which number goes where. You're on the right track though. That's a
Apply the angle times 2 and then take away the 74 and get the other arc.
There you go. Good. So here's essentially what Isaiah is saying. He's going, look, in this other problem over here, we did arc plus arc divided by 2 gave us the angle. We're going to do the same thing here. We're essentially just going to undo it like it's an algebra problem and solve for the piece that we don't know. So I don't know what this arc is right here. Because that's what you're trying to solve for, if you want, we can put an X there. And then I'm going to write it using the same equation I just used before. The arc plus the arc divided by 2 equals the angle. So my 2 arcs are 74, and my unknown arc over here is just X. So I'm trying to find. I divide that by 2, and that should equal what number? It should equal 62. Yep. So it just becomes an algebra problem, and I'm solving for X. So what would be the first thing I would do? Whoa, no. Get rid of the divided by 2. Get rid of it. Get rid of fractions. What's the opposite of divided by 2? Multiply by 2. Because if you try to divide the 74 by 2, you also would have to divide the X by 2. Which you can't do. It's just going to make it more messy. All right, so I'm just undoing everything now. My 2's on the left will cancel. I've got 74 plus X equals 124. And then I do what? Subtract the 74. Good. And you get X equals 50 degrees. So this angle out here, this arc, excuse me, arc LK is 50 degrees. How could I check my work to see if I was right? plug it back in. So if I do 50 plus 74 divided by 2, what number should I get? 62 right in the center. Yes. So if you're ever not sure, plug it in. Additionally, if it's a multiple choice question and you didn't know how to do this piece over here, they give you a choice, just plug it in. See if it comes out to be the right number. Right? That's one of your strategies, is just plug the numbers in that they give you. All right. Questions so far? Okay. Yes. But that's okay, because you already know this angle is 62. How would you figure out the other angle right over here? What did we do in the last problem? Subtracted from 180. Yeah, so I could say this whole thing's 180. This is 62. So if I subtract the 2, I get 118. So this angle is 118, which means what's this angle? 118. And what's this angle? 62. So it's not hard, but you are going to have to know how to do that, because that is definitely going to be a question on your exam. I don't know how they'll give it to you, but it's definitely going to be some questions that you'll see. Good question. I know it's not the answer you wanted to hear, but good question. All right, I'm going to skip 5 and 6 for the moment. We'll come back to them. Next one is on the circle intersections. So we just did interior intersections on the inside. Now we're doing intersections on the circle. So this theorem says if a line that goes through the circle and a line that is on the edge of the circle meet at a point on the circle, so this point is called the point of tangency, meets on the circle, then the measure of each angle formed is equal to half the measure of its intercepted arc. So the angle is equal to half of the arc measure. So here's what that means. Here's angle 1 on the left. Angle 1 is from the top of the line all the way to the bottom of the line. That's a full angle, so part of it is outside of the circle. To find the measure of this angle 1, I need to take the arc that it touches and divide it by 2. So the arc that angle 1 touches is arc BA. So to find the measure of angle 1, I'm going to take arc BA and divide it by 2. And that will give me the measure of angle 1. It's an intercepted arc. We've seen these before. We did this last week. You just take the arc and divide it by 2. Same idea for this angle 2 over here. I need to find the arc that it intercepts and divide it by 2. What's the name of the arc that this angle touches? BCA. Good. So arc BCA, whatever that really big one is, I'm going to divide it by 2. So in other words, my angle equals the arc divided by 2. All right, let's try an example. Number 7. Find the measure of arc angle, DEG. DEG is this whole thing right here. So I need to take the arc that it matches with and divide it by 2. So what's the name of the arc that it matches with? Well, H is just a point. I need the whole name. EHG is this whole arc. And what's the measure of the whole arc? 308. So I'm just going to take 308 and divide it by 2. So angle DEG is what?
154.
154 what?
Degree.
Degrees. And you're done. That's it. So you take the arc and divide it by 2. Simple, right? Let's try the next one. Number 8. Angle DBC. DBC is this angle right here in pink. Now, what's the problem with this question? It doesn't give me everything that I need. It doesn't give me the arc that I need, which is the arc over here at the bottom. What am I going to do? Beautiful. Whole thing's 360. To find arc DB, I'm going to take 360 and subtract what I already know, which is 192. And that'll give me the arc right over here. So if I take away 192 from 360, I get 168 degrees. And that's the full arc from D to B. But then how do I find angle DBC? Divide it by 2. Perfect. So angle DBC is 84 degrees. Yes, perfect. So look, you had one extra step in that one, but as long as you remember a full circle's 360, you can always figure out the other arc marks that are given to you or that are left over. Okay, number 9. Last one on the front. What's different about number 9? You're finding an arc this time, not an angle measure. So I want to find arc XY. XY, which is very small, it's right over here. Now, there are a lot of different ways you could go about this problem. But right now, if you look at that arc, you don't have the arc measure, and you definitely don't have the angle that goes along with it. The only thing you have is that this very large arc here is 151 degrees. So that's from here to here is 151. So, ideas. What do you think?
180 minus 151.
Multiply 151 by 2 and then subtract that from 260.
Okay. There's one way. And Isaiah, you said the second way. There's 2 different ways to do this problem. So Katie, say your way again.
You multiply 151 by 2 and then subtract that from 260.
Okay. So Katie's saying, hey, this is 151. I can figure out this arc over here by multiplying that by 2, right? Because it's the angle. I want to get to the arc. So you could multiply 151 times 2. And you get what? Well, that whole thing is 302. And then you can take 302 away from 360 to get what's left over. Okay, that's one way to do it. Isaiah, what was the way you were saying to do it?
180 minus 151. And then get the angle from the other side. The angle by 2.
You get the exact same thing, right? So Isaiah is saying, hey, this is a straight line of 180. I can subtract 151 from 180. And you get, what is that, 29? 180. Yep, you get 29 degrees. So this angle in here is 29 degrees, and then he multiplied 29 times 2 to get the arc over here. And he also got 58 degrees. So you can do it either way. You're going to get the same answer. It does not matter to me which way you want to do it. If you like subtracting from 360, go that route. If you like using a straight line as 180, use that route. I don't care. As long as you get the right answer. Awesome. All right, flip it over. We're getting there. We're close. We're close. Okay. Last one. Exterior intersections. What does exterior mean? Outside of the circle. Okay, so this time we did ones that were inside the circle. We did one that was on the circle. Now we're doing lines that are outside of the circle. Now, while there are 3 different kind of ways that you can have lines that intersect on the outside of the circle, the rule for all 3 of them is going to be exactly the same thing. And the rule for all 3 of them is you take, to find the measure of the angle, you take half the difference of the intercepted arcs. What does the word difference mean you're doing? Subtracting. So before we were adding, now we're going to be doing some subtraction. Now there are 3 different ways you can see lines on the outside of your circle. The first one is called 2 secants. That means 2 lines that go through the circle. A secant and a tangent is a line that goes through and a line that's on the circle. And then 2 tangents is 2 lines that are on the circle. But they all have the exact same formula. You subtract the measures of the arcs and then divide by 2. So I'll show you what I mean. In the first one, to find the measure of angle A, which is all the way out here on the exterior of the circle, you're going to take the larger arc that's intercepted and subtract the smaller arc that's intercepted. So the larger arc, if you follow the arrows, is this arc right over here, CE. That's the large arc. What's the smaller arc that's intercepted? BD is the smaller one. So the formula for this picture is CE, arc CE, minus arc BD divided by 2. So it's the big arc minus the small arc divided by 2. And that's for all of these. Big arc minus the small arc divided by 2. That's for all of them. So take a look at the next picture. Big arc minus the small arc divided by 2. What's the big arc in that picture that's being intercepted? So follow these 2 lines. One hits here, one hits here. What's the big arc, the name of it? BD is the big arc, minus, what's the small arc? BC on the interior. Yeah. So BD minus BC, and then divide by 2. Big arc minus the small arc. Okay, same for the very last one. 2 tangents that are on the edge of the circle. I take the big arc minus the small arc. What's the name of the big arc here? What's the name of that really big arc? Oh, it's not just BC. BDC, yeah. BDC minus, what's the small arc? BC divided by 2. Okay, same formula for all of them. Big arc minus the small arc divided by 2. So let's try it out. Number 10. Finding angle KLM. KLM. So this angle on the outside over here. Okay, I'm going to do the big arc minus the small arc divided by 2. What is the big arc? JN. Minus, what's the small arc?
K.
KM. And divide by 2. Big arc minus the small arc divided by 2. So 140 minus 66, and then divide by 2. What do you got? Is that 74? 37? Yeah, no? Anyone? Yes, okay. Just doing it in my brain here, people.
37.
Good. Beautiful. There you go. You figured it out. Big minus small divided by 2. Easy peasy. Let's try the next one. Questions on that one? Feeling good? Okay, number 11. Let's name them. What is your big arc in number 11?
DA.
DA is your big arc. Good. Minus, what's your small arc?
AC or CA.
AC or CA, whichever way you want to write it. Divided by 2. Now what's my problem? I don't know the big arc. I don't know DA. How am I going to figure it out? Close. Close, close, close. If I have 3/6, that's the whole circle, and I subtract 88, I still have 2 pieces of the circle left. I only want to know 1 piece of the circle up here. What else should I take away from the 360?
62.
I also need to take the 62 away, because if I don't take that 62 away, then I'm figuring out this whole arc from D all the way around to C. So to figure out arc DA right over here, it's exactly what I'm going to do. Yep. But I'm going to write it as 360 minus 88 plus 62. But yes, that's exactly what I'm going to do. So that's 150. What is it? 150. So that's 210. Yeah? No? Maybe so?
Yeah.
210 degrees. So this arc up here is 210 degrees. And now I got to plug it into the equation. Big minus small divided by 2. So what does your equation look like? 210 minus 62 divided by 2. Good. So angle
Equals 74 degrees.
Beautiful. 74 degrees. Fantastic. Okay, so you are going to have to figure out some other pieces before you can physically do some of the questions sometimes. And that's really, those are the types of questions you're going to see on your exam, where you're going to have to figure out something else first before you can answer the question. All right, try number 12, and then we'll be done for today. Try number 12 to see if we get the same answer. Give it a go. Try number 12. Remember, a full circle is 360. That should help you out significantly. All right, what did you get for your angle? Katie got 133. Lily got 133. Anyone else? Dom did. Yeah? No? Maybe so?
Yep, that's that.
Beautiful. 133. Good. So you took your 313 away from the 360 to get that arc PR to get 47 there. And then once you figured that out, you could plug it into the equation of big minus small divided by 2. Now, your homework tonight is to complete the problems that are left over. That is 7 problems you are going to complete. 5 on the back, 2 on the front. Personally, I think 7 questions, you should be able to finish that in about 10 to 15 minutes. Shouldn't take you longer than that. You do not have to submit it anywhere, but I am going to check it in class tomorrow. So make sure that you do it.